So this is a quick video to review how to do Lewis structures. You're going to follow these 4 steps. You're going to count your valence electrons, draw the skeleton structure. Any element that gets 8 electrons gets 8 electrons. And then you're going to count your electrons again and see if you were right. So let's remember on the drawing the skeleton structure. The element you put in the middle is usually the one that can make the most number of bonds. So think about something that has a valence electron of 5. It can make 3 bonds. Something that has 7 valence electrons can only make 1. So you'd put the one that can make the 3 bonds in the middle. And then this part here about elements getting 8 electrons. From the carbon column all the way to the noble gases, so columns 14 through 18, they all get at least 8 electrons. And you'll see later that some will violate that octet rule. The ones that are in columns 1, 2, and 13, they will never make 8 electrons because they can only make 1, 2, or 3 bonds. So be careful on things like that. So let's take a look at 2 very quick basic examples. Here we have water. Number 1, count your valence electrons. Each hydrogen is 1, so that'll be 2. Each oxygen is 6, so that's a total of 8. Now, O has 6, so it can make 2 bonds. So put O in the middle, put an H on either end, and then anybody who deserves 8 gets 8, so that would be oxygen. H cannot, it only has 2 bonds, it can only make 1 bond, that's it. And then you go back and count again. Remember the lines count as 2, so 2, 4, 6, 8. And we did it. And now, of course, my Lewis structure looks funny, right? So we do have it correct. So let me just get rid of some of this here real fast. Maybe not. Let's just put this back in. Sorry, you guys. I have the wrong setting on. It's okay. So it should look like that. Ignore those other dots. All right, let's try NH3. N's 5. Each H is 1, so that's 3, so you get 8. Again, N's going to go in the middle. It can make the most bonds. Put those H's around and put a pair of dots on the N, and you have 8. Pretty straightforward. We also don't try to show shape with Lewis structures. We usually just draw like a plus sign for the tetrahedral and whatnot. So don't feel like you have to make the shapes happen as well. All right, what do you do if you do all that and you have too many electrons? So let's walk you through N2. N2 has 5 and 5, so 10. So obviously you're going to connect the ends, give them 8. And when you do that, you get 2, 4, 6, 8, 10, 12, 14. You have too many. What you need to do is you need to remove a pair of electrons from both elements. So remove that pair, remove that pair, and now you can put a double bond in. Count again, 2, 4, 6, 8, 10, 12. I still have too many. So again, remove from each. You did not go away, you little booger. There we go. And then you can put it in there. So N2 has a triple bond. And if you count, you get 10. So if you do the same thing with CO2, 4 plus 12 is 16. Sorry, I've drawn this one so many times. I just happen to have it memorized. So count, do your skeleton structure, give everybody who deserves 8, 8, and then count. Now when you count in this configuration, you get 20. You have too many. So remove a pair from the carbon and remove a pair from the oxygen. Now you can go ahead and put a double bond there. Now we have 18. So do it again. Remove a pair from the oxygen. Remove a pair from the carbon. Remove a pair from the carbon. Don't you love when technology doesn't work? And you have 16. So if you have too many, you're going to make either a double bond or a triple bond, or both, or whatever. What if you don't have enough electrons? So let me show you on this one. Xe is 8. I know, I've always said the noble gases don't do anything. I lied. And then each bromine is 7, so that's 14, and you're going to get 22. So Xe goes in the middle. Some of our noble gases actually do something. And when you give everybody their dots, you're going to get 20, okay? But we just said we need 22. So if you don't have enough, add a pair to the middle element. Now you have 22. So yes, this violates the octet rule. Notice Xe has 10 electrons around it, not 8. Other ones that violate the octet rule are the following. AlCl. Al only has 3. Chlorines are 21 altogether, so we get 24. Al is going to go in the middle with the Cl's all around, all right? And you know all the Cl's are going to get their dots. But does Al get dots? No, it doesn't. It is in column 13. It has 3 valence electrons. It can only make 3 bonds because it's going to give those away. And if you count, you have 8, 8, and 8, which is 24. PCl5 is another one of those, and it's got 5 Cl's. I don't even try to show the geometry. I'll just stick them on there somewhere. And when you give all of the chlorines dots, I'm going to skip that for this video, you get 8, 8, 8, 8, 8. 8 times 5 is 40. I forgot to do this up here. 7 times 5 is 35, plus 5, 40, and you get it. So aluminum only does 6 electrons bonded, but P can do 10 electrons. SCl6 is another one. 6 and then 7 times 6 is 42. It does help to know your multiples. So put S in the middle, put those Cl's all out there. I'm just going to skip it for the sake of time. And you do get 48. So S can actually have 12 electrons around it. MgCl2, you have 2 and 14, and you get 16. So put the Mg there, put the Cl on either side. And you wouldn't draw the Cl's closer together because electrons don't like each other. They want to be far apart. And guys, that's 16. Mg is in column 2. It can only make 2 electrons. And what did I mean by that? You wouldn't draw this like Cl here and Cl here because all those electrons repel. They want to be as far apart as possible. So make sure you do that. Now, I'm not going to mark it wrong, but if you go on and take a college course, they're going to be a little bit more particular about that. So I hope that helps you understand a little bit more about doing Lewis structures.